You are probably looking at a screen right now, like a flat piece of glass, maybe a
Yeah.
computer monitor, or even just your phone.
Right, something totally flat.
And your brain is entirely convinced there is a three-dimensional world inside of it. Like you see depth, you see distance.
You feel like you could just reach into it.
Exactly. But what if I told you that the optical trick making you believe in that digital space is the exact same flaw that might be, well, that might be breaking our models of foundational physics?
I mean, it is basically the ultimate blind spot. We are constantly interacting with this incredibly sophisticated illusion.
Yeah.
And the crazy part is we have built our entire understanding of reality on top of it, from, video game engines all the way up to astrophysics.
Which is wild to think about. Welcome to today's deep dive, everyone. We are unpacking a really fascinating set of concepts today that merge 3D graphics theory, human anatomy, architecture, and even physics.
It is a pretty broad mix of disciplines.
It really is. The mission here is to figure out how human consciousness actually constructs what we call space, like how we are actively tricked by 3D coordinates on 2D screens.
And why even the most famous models of physics might have a critical mechanical flaw when it comes to the true nature of observation.
Right. So to kick things off, what are we really examining here?
So what we're really looking at is the massive friction between pure abstract mathematical space and what the source material calls the deception world of human visual perception.
The deception world, I like that.
Yeah, because in pure math, space is perfect, right? Everything happens simultaneously. But in human perception, biology, time delays, and lines of sight dictate a reality that just isn't quite what it seems.
Okay, so to understand how we construct this space, we first have to look at the interface between us and the digital world. That monitor screen you were looking at right now.
The flat piece of glass.
Exactly. Mathematically, we can actually define this flat screen as the y=0 plane, specifically the zx plane.
Let's visualize those axes to make it concrete for everyone listening. If you are sitting at your desk looking at a monitor, the z-axis is running vertically.
Straight up and down your screen.
Right. And the x-axis is running horizontally, like left and right.
And that flat plane, that y=0 screen, is literally bisecting the entire 3D universe. It partitions reality into two half spaces.
It splits it right down the middle.
You have the positive I space, which is the physical, breathing room you're sitting in. And then you have the negative Y space, which is the digital abstraction living behind the glass.
It acts as an absolute boundary. And to understand how we interact with that boundary, I think it helps to think about the mechanics of a third-person perspective video game.
Oh, like a third-person shooter or an RPG.
Yeah, exactly. In a third-person perspective, it is as if you are physically inside your room, looking out through a transparent window, your screen, at a dummy figure standing outside in that digital void.
The orientation of that dummy figure is super crucial here. Imagine a simple 3D model of a person standing on the other side of your screen.
Facing back at you.
Right. Its vertical spine, straight up and down, aligns with that blue z-axis. Its arms, outstretched to the left and right, form the red x-axis.
And its line of sight, looking directly forward back at you through the screen, is the green y-axis.
Okay, so that dummy represents a purely mathematical global coordinate system. It is perfect. It is objective.
But the moment a biological human observer looks at it through a flat 2D screen, we force that perfect 3D abstraction onto a flat surface.
We introduce human consciousness.
Right, with all of its biological limitations right into the mix.
Think of a surgeon wearing augmented reality goggles. Their physical arms, their real-world depth perception, those anchor their biological worldview, like they know exactly where the scalpel is in the physical room.
Because they have real physical spatial awareness.
Exactly. But when data is projected onto the flat 2D lenses of those goggles, they are entering that deception world. The technology forces their biological consciousness to interpret a flat image as a 3D reality.
And we do this every single time we look at a screen. We just implicitly accept the illusion of depth without questioning the mechanics of it.
Right. So because we establish that the screen is an absolute boundary window, the natural next step is to ask, how do we actually pull depth information out of a completely flat plane?
Right, because it's completely flat.
Wait, isn't it just like a camera? Like we just passively receive the light coming off the pixels, don't we?
Well, that is how we usually think of it, but biologically and perceptually, human vision functions much more like active sonar.
Active sonar, like a submarine.
Basically, yeah. We don't just receive light passively. We project. We literally shoot our line of sight, our personal axis, straight through that screen plane to probe the environment.
Oh, I see what you mean. We are actively locking onto targets.
Exactly. And the physical reality of this creates a massive bottleneck. Think about your eye.
Yeah.
You have the fovea centralis in your retina.
That's the tiny microscopic pit responsible for your really sharp central vision.
Yeah, right. Mathematically, you can treat this fovea as a one-point world, a single point of reception. But it's interacting with a monitor screen made up of millions of individual pixels.
A many-point world.
Exactly. You have this many-to-one relationship. Millions of points of data being forced through a single biological receptor.
And that physical bottleneck introduces a pretty profound problem regarding time and information delay, doesn't it?
It does. It fundamentally alters how we experience reality.
Let me stop you there, though.
Yeah.
Because if I'm playing a game or watching a live video feed, I'm seeing it instantly. Are you saying the screen itself is creating a delay, or is it my eyes?
It is actually the fundamental nature of light itself, compounded by our biology. Let's step away from the digital screen for a second and use a real-world visual.
Okay, let's hear.
Imagine standing on the observation deck of the Yokohama Landmark Tower. You are looking out through these massive glass windows at the entire city skyline stretching out for miles.
Okay, I am picturing it. I am receiving light rays from thousands of buildings, cars, and streetlights. And all of that light is hitting my eye at the exact same moment.
Right, it hits your retina simultaneously. But the information itself is completely fractured in time.
Fractured in time? How do you mean?
Well, the light from a building 10 miles away took longer to reach your eye than the light from a pigeon flying right outside the window.
Oh, wow. Yeah, obviously it did.
But because they strike your biological bottleneck at the exact same nanosecond, your brain treats them as simultaneous.
So our minds basically instantly retrieve these overlapping memories. Light from a microsecond ago, light from a nanosecond ago, and we falsely stitch them all together.
We build a completely flat map, and we call it the simultaneous present.
We build our now out of a million different pasts. That is wild.
It is a fabricated simultaneity. We treat the image on our retina as a real-time slice of the universe.
Which completely flies in the face of how physics usually maps time. Like, usually you get shown the Minkowski space-time diagram.
The two cones touching at the tips.
Exactly. The past light cone below, the future light cone above, separated by the infinitely thin present moment. But visually, in the pure image world our brain constructs, that depth of time doesn't even exist.
No, it doesn't. Our minds just smash the past and future light cones together right at the window of our eye.
That is a really vital distinction. In the purely visual realm, we flatten time into geometry.
Think about it in terms of tracking a moving target. If you are trying to hit a baseball or, say, intercept a plane, you can't react to where the object appears to be right now.
Because that image is already historical data.
Right. To hit it, you have to project your active sonar forward. You have to deviate shoot into the base of the future light cone.
Deviate shoot. So you are interacting with a future probability based on a delayed flat image.
Exactly. Now, if our brains are already struggling to stitch together delayed light from a few miles away in a city skyline, what happens when we look at light that took centuries to get here?
You mean looking at the night sky?
Exactly. What happens when we look up at the stars?
We take this fabricated simultaneity to a completely cosmic scale. Imagine the sun as the origin point of a massive 3D grid. Coordinates 0, 0, 0.
Like the center of the universe.
Right. Think of the sun as a Wimbledon umpire sitting high up in the chair right at center court.
Okay, I like this analogy. So from that umpire's chair, we look up into the deep night sky and we pick out three distinct stars. Let's say Sirius, Betelgeuse, and Polaris.
Now, when we look up at Sirius, Betelgeuse, and Polaris, those three distinct points automatically lock down a specific 2D plane in space.
Right, because any 3 points in a 3D void give you a flat triangle and therefore a plane.
Exactly. In mathematics, this is governed by the equation of a plane. You often see it written as ax plus by plus cz plus d equals 0.
But for our purposes, you can just think of those letters, the A, B, C, as dials.
Dials, like on a soundboard.
Kind of, yeah. In 3D graphics software, when you turn those dials, you tilt that flat starry plane. It dictates exactly how the observer has to twist their neck or orient their camera to view it.
Oh, I see.
The software literally calculates the absolute shortest distance from the sun to the starry plane, dropping a perpendicular line straight down to create what we call a look-at vector.
But going back to our Wimbledon umpire metaphor, here is the massive perceptual trap. The umpire is looking up at Sirius, Betelgeuse, and Polaris and judging exactly when the light hits their eye.
And the umpire calls all three in at the exact same moment.
Right. They look at this starry plane and mistakenly grasp it as a simultaneous reality right now at t=0.
Completely ignoring the fact that the light from Sirius is like 8 years old, while the light from Polaris is hundreds of years old.
The umpire is ruling on balls that were hit centuries apart, but treating them as a single simultaneous volley. We take the massive depth of time and we compress it into a geometric 2D surface.
So we've seen how 3 points lock down a single specific 2D plane. But this leads us to an even deeper, much more problematic paradox.
Which is really the absolute core of our deep dive today.
Yeah. What happens if we reduce our observation? What if we don't have 3 stars but only 2?
This is where we cross from basic geometry into a real breakdown of objective reality. Imagine we are only observing 2 bright spots in the dark.
Just 2 points. Connect them, and they form a single-line segment.
And as observers, we share a recognition of this single-line segment. It is a shared subject. You see a line, I see a line. It's undeniable. The line segment is a fact.
It is absolutely a fact. However, unlike a triangle which firmly locks down one specific plane.
Right, because of the 3 points.
Exactly. Unlike the triangle, this single-line segment belongs to 2 intersecting planes. In fact, mathematically, it belongs to an infinite number of intersecting planes in 3D space.
Wait, really? Infinite planes.
Think about holding a flat piece of paper with a straight line drawn right down the middle of it.
Okay, I am holding it.
If you hold it perfectly flat at eye level, you see a line. Now, if you tilt the paper up 45 degrees, you still see a line.
Oh, wow. The visual fact of the line didn't change at all, but the actual plane it lives on, the tilt of the paper, completely changed.
And here's the breaking point. As the number of observers in the room increases, the number of potential planes that this factual line segment could belong to increases by the exact number of observers.
Because every single observer is looking from a slightly different angle. They're shooting their active sonar from a totally different coordinate.
Precisely. So for every new pair of eyes, there is a new hidden plane that the line could belong to.
The line segment is an undeniable fact, but which specific plane it belongs to is a completely unknown world just by looking at the 2D image.
Yeah.
You simply cannot extract the plane's tilt from the line itself.
You really can't. But humans, and certainly our physics and computer models, we really hate the unknown.
We absolutely do.
So what do? We cheat.
We cheat. How?
Even though we don't know the plane, we use what's called an orthographic projection trick. We take the visual of the flat line, we guess the plane based on our own selfish viewing angle, and we force it into our 3D coordinate system anyway.
It is identical to a designer taking a flat, 2D architectural blueprint, like a standard 3-view drawing of a house, and just inputting those raw numbers into a 3D simulation space.
Exactly like that. The blueprint is flat. It contains 0 actual depth. But they type the values into the software to generate a 3D volume.
So observing this line segment is fundamentally an observation of a surface, a 2D plane. But the very second we try to resolve it, the moment we ask, well, which plane is this, we are forced to construct a 3D space.
Right. Exploring a flat surface instantly becomes a conversation about 3 dimensions. We are building 3D simulations out of 2D assumptions.
We pretend that our specific localized viewing angle is the universal objective truth. We assume our active sonar is the only one that really matters.
We project our assumptions onto reality just to make it functional. And this projection trick isn't just a quirk of how video games render graphics, it dictates how we build entire cities.
And as we'll see, it might even dictate how we historically defined modern physics. Let's map out how this distortion scales up.
Think about the translation of reality in architecture. We can break it down into 3 scales. First, you have the alpha scale. This is the purely abstract coordinate space.
Think of urban planning or zoning laws. It's pure mathematics, like a top-down, frictionless grid of a city.
Then you have the beta scale. This is the architect. The architect takes that abstract alpha grid and starts visualizing a specific physical building.
They transition from pure 3D space into drafting a flat 2D blueprint. They basically compress reality.
And finally, you get to the gamma scale, the carpenter or the builder on the ground. They are looking at the specific parts, they read the flat 2D blueprint, and try to reconstruct the 3D physical reality from it.
So the architect shifts from building the space in their mind to observing the flat blueprint, and the carpenter shifts from the flat blueprint back to physical space.
It is a constant translation between 2D images and 3D reality, and every single time you translate between those dimensions, you introduce a massive potential for that orthographic projection trick to cause distortions.
Data gets lost, and assumptions fill the gaps.
To really visualize this distortion, imagine a transparent globe of the Earth. Right at the very center, the core of the Earth, a light bulb flashes at t=0.
Okay, I've got it.
It shoots infinite light rays outward. At t=1, those rays pass through the surface of the globe.
Now, wrap a flat cylinder of paper around the Earth. Those light rays project the shapes of the continents onto the paper. When you unroll it, you have a completely flat map.
This is exactly how Mercator map projections are made. It's a one-to-one mapping. Every point on the globe hits one point on the paper.
But because you are projecting from a 3D sphere to a flat 2D cylinder, the edges get wildly distorted. Like, Greenland looks larger than Africa on those maps, which is physically absurd.
The flat map is functional for navigation, but it is a highly distorted illusion of physical reality.
Which brings us to the ultimate consequence of this illusion. How does this map projection distortion apply to the observation of events in fundamental physics?
Let's set up a classic physics scenario with two observers. Observer 1 is sitting right at the origin point 0, 0, 0. Observer 2 is positioned far away at the camera eye. Let's say their coordinates are 0, -10, 30.
Okay, so they are pretty far apart. Now, a visual event happens at a window far away at y=40. Light diffuses from that window. It travels and hits observer 2 directly.
But that exact same light also travels to observer 1. And observer 1 might react or pass that information along to observer 2.
So observer 2 is receiving direct visual information with one specific time delay and secondary information via observer 1 with a completely different time delay.
It creates an incredibly complex web of delayed information, all distorted by relative positions, angles, and the inflexible wait time of light.
And this right here is the mechanical critique leveled at the history of physics in our source material. Imagine you are the architect of reality for a second.
If you build a physics model based purely on the flat map you see in front of you, this web of delayed light, you are building a house on a foundation of optical illusions.
This is what the text refers to as Einstein's slack. And to be clear to you listening, we are purely analyzing the mechanical argument of the text here without taking any sides on the actual science. We are just unpacking the source.
Absolutely. So the claim being made is that special relativity took this real number space, a space already heavily distorted by these relative velocities and the highly varied wait times of light from multiple observers, and it mapped it exactly as it appeared.
The argument is that the theory assumed two different mathematical planes could just rub together at zero distance. It completely bypassed a crucial mechanical step.
It completely ignored the need to first generate the coordinate space from the observer's specific line of sight and rotation.
It took the distorted Mercator map, saw a massive Greenland, and treated it as the fundamental, undeniable territory.
It didn't account for the orthographic projection trick that created the flat map in the first place. It treated the line segment as an absolute 3D reality without acknowledging the infinite unknown planes it could actually belong to.
It's a staggering thought, honestly. Whether you agree with the critique of relativity or not, it forces you to reevaluate how much of our objective reality is really just biological guesswork.
We assume our visual map is the territory. We forget the wait time of light, we flatten time into a simultaneous image, and we project our localized 2D perspective into a 3D absolute.
Let's pull all of this together because we've fundamentally broken down how we see the world today. We started at the boundary, the 2D window of the monitor screen, the y=0 plane, that basically partitions our physical universe from the digital void.
And from there, we realized we aren't passive cameras. We use our vision as active sonar. We project out, gather delayed light from the past, and our brains instantly smash it into a false, flat map of the simultaneous present.
Which is the exact same optical illusion that happens when we look at a starry night sky. We see a triangle of stars, we lock down a flat plane, and we completely ignore the centuries of dead time hiding between those points of light. We just treat it all as now.
And that brought us to the core realization regarding the line segment. A shared, undeniable visual fact, just a simple line, that actually exists in an unknown world of infinite possible planes.
Planes that multiply with every single observer who looks at it. But because we can't handle that unknown, we use a trick.
We guess the plane, we orthographically project it into a 3D coordinate system, and we build our architecture, our simulations, and perhaps even our fundamental physics upon that unproven assumption.
Exploring a flat surface forces us to invent a 3D space just to make sense of it.
It is a really humbling reminder that our standard coordinates, the very math we use to navigate the universe, might be resting on a biological projection trick.
It fundamentally changes how you process information. So, as we wrap up this deep dive, I want to leave you with a final thought to carry with you.
The next time you look at a simple flat line, whether it is a trend line on a graph at work, a property boundary, or even just the horizon in the distance, ask yourself this.
How many unseen dimensions, how many alternate intersecting planes are hiding inside that single undeniable fact simply because of the specific place you happen to be standing?
The reality you see is really only one of infinite projections.
Keep questioning your perspective. Thanks for joining us on this deep dive. See you next time.